let us learn about the second lecture of this chapter, reflection and spherical mirrors. Now, what is reflection? I think every one of us know what is reflection statement, right? The bouncing back property of the light is known as reflection. That means whenever a light hits an opaque surface, it will bounce back. That is property is known as reflection. For example, let us, we all play cricket, right? Yes, when we play cricket, when a bowler bowls, the ball hits the ground and it will bounce back. It will not go into the ground, right? So the same thing happens with the light. When, let us think this is an opaque surface, when the light hits the ground at a point, it will bounce back. This property is known as reflection. The light ray which is incidenting the ground is known as incident ray. It is denoted with I. The light ray after hitting the ground will bounce back. That is known as reflected ray. And thus the point where it makes the contact is known as normal. Now, what is here we need to learn a few terms about it. Incident ray, reflected ray and normal. Now, what is incident ray? The incoming light ray, when it falls on the ground, that is known as incident ray. After hitting the ground, if it starts bouncing back, that is known as reflected ray. And the point where it touches the ground, that perpendicular is known as normal. Now, after a few minutes, we're gonna learn why do you call it a light as a ray. Let us discuss a few minutes later. For time being now, what are the laws of reflection? There are two laws of reflections. There are two laws of reflections. What are they? First law. First law states that the angle made with the incident ray with the normal is equal to the angle between normal and the reflected ray. As I said, it is a normal. This angle is equal to angle R. That is, the first law is angle I is equal to angle R. The second law states that R, I and normal lies on same plane. I have took an example of a cricket ball, right? When I put the ball on the ground, it is not going to the ground. It is bouncing back. That means even in the reflection, the light it will changes the path but not the medium. It remains in the same medium but it only changes the path. This first law, second law is not only valid for one plane mirrors or spherical mirrors. Whatever the mirror might be, it might be a plane mirror, it might be a spherical mirror, whatsoever the mirror is, it is valid. Why did I describe a light with a ray? Because ray has only starting point and we don't know the end point. It goes on continues. The same thing happens with the light, right? So that is the reason I use the term ray, that is incident ray, reflected ray, because we have only the starting point but not the end point. So this is the reason I use the word ray. Now, have you ever seen some round mirrors which are installed at the road, at the corners of the road? Yes, right? Nowadays they are installing it. Yes, they are not plain then. What are they? Are they mirrors? Yes, there are mirrors. But what sort of mirrors are there? Yes, this type of mirrors are called as spherical mirrors. All these types of mirrors which are not plain in nature are called as spherical mirrors. Now, what are spherical mirrors? The mirrors whose reflecting surface is not plane is known as spherical mirrors. So, how many types of spherical mirrors we have? We have two types of spherical mirrors. They are concave and convex. Concave mirrors are the mirrors whose reflecting surface is inward. They are also known as converging mirrors. Like this inner surface is a reflecting surface. I'll explain what these terms and why I'm drawing like this and all. But for time being, let us understand that the reflecting surface is inside. The mirrors whose reflecting surface is inside is known as concave mirror. The same concave mirror whose reflecting surface is outside is known as convex mirrors. Let us come back to the example which I have said. When there is a turning, when there's a U-turn, when there's a U-curve turn, or whenever it is like this, we are seeing that installing of big mirrors, right? I think you all have seen, right? Yes, we can see that on the roads in Hyderabad also. Now, why are they placed? What do they do? Next, we all play with the spoon, right? When we eat something, we play with the spoon, right? Small children are familiar with that. You take a spoon, you keep it like this, you see your image in some changing ways, and immediately you'll turn it back and you see it in another way. This is a basic example to say about concave and convex mirrors. Whenever you're looking like this part, the reflecting surface is in face and it represents a concave mirror as the reflecting surface is inside. The spoon, if this is the spoon, this outside acts as a convex mirror and the inside acts as a concave mirror. This concave mirror is called as converging mirrors because the light rays which falls in the mirror, it will converge them to a point called as focus. The light rays which fall on a convex mirrors will be diverged, so it is known as diverging mirror. As I discussed earlier, that concave mirrors and convex mirrors. The concave mirrors are the mirrors which have the reflecting surface inside. Convex mirrors are the mirrors which have the reflecting surface outside. That means for the concave mirrors, the outside is silver coated. So only the inner one will be acting as a reflecting surface, and that is known as concave mirror. For convex, the inner one is silver coated, the outer one acts as a reflecting surface. Okay, fine, but what are they actually? From where did we get this type of mirrors? These are a part of a big sphere. If you break down a sphere into two parts, you get a concave mirror and a convex mirror. Concave part is one which has the outer coat as a silver coating, and the convex will have the inner one as a silver coating. Now let us see the normals of the curved mirrors. Now we know we can easily say the normals to the plane mirrors, right? Now let us see about concave and convex mirrors. First of all, consider a foam. It might be a cardboard or a leather foam. Now like this, take a cardboard foam, insert pins at regular points. When this is a plane, they act as normals, we already know that. Now if I bend it inwards, it looks like this, which represents the concave mirror. Here when I bend it, the pins represents the normals to the concave mirrors. Now you can see that they started converging. When I bend it inwards, the normals are, if I continue them, they look like converging. So that is why it is known as converging mirrors. Now the vice versa with the convex mirrors. If I bend the sole outward, it looks like a convex mirrors, where again the pins seems they are diverging, as it is a diverging mirror. Now this simply can be understood like from center, if you drop any line onto the curvature, they are normals. They are normals. And the light follows the laws of reflection that angle I equal to angle R. Hope so you people have understood what normals to the curved mirrors of concave and convex mirrors. Now let us see some of the important terms associated with the spherical mirrors. Some of the important terms are pole, principal axis, center of curvature, radius of curvature, focus and focal length. Now let us learn each one individually. Now what is pole? Now we all know that this is a concave mirror, right? Yes. How? Because the reflecting surface is inside. Now what are these terms associated with this? The geometrical midpoint of the concave mirror is known as pole. What is principal axis? Before learning about principal axis, let us see what is center of curvature. This point is known as center of curvature. This is nothing but, I said it belongs to the original sphere, right? So what was the center of the original sphere? That becomes the center of this curvature. That is the reason I am saying it as curvature, because it's a part of the spherical mirror. Now what is principal axis? The line which passes through pole and center of curvature is known as principal axis. Principal axis is nothing but the line which passes through pole and center of curvature. Now what is radius of curvature? We all know what is radius, right? What is radius? The distance from the center to the any point on the circle is known as radius. As this is a part of a sphere, it means a circle. Here the radius of curvature is nothing but the distance from the pole to the center of curvature. Here children will be confusing between principal axis and radius of curvature. Principal axis is the axis which continues even beyond the sea. It is a line which passes from the pole to center of curvature. It passes through it. But radius of curvature is the one which starts at pole and ends at center of curvature. Next, what is focus? When the light rays fall on the mirror, they undergo reflection. All the reflected rays, they meet at a point known as focus, where you can see a clear image. So focus is nothing but the point where all the reflected rays meet. It is known as focus. Next, what is focal length. The distance between the pole and the focus is known as focal length, which is denoted with f. Now we have certain terms which shortcut like pole is represented with p, center of curvature is denoted with c, radius of curvature is denoted with r, focus is denoted with capital F, and focal length is denoted by small f. And here we have an important formula, right? R equal to 2 into focal length, which we use this in derivations of image formula. Let us do an activity to observe the types of images and measure the object distances and image distance from the mirror. For this, we require a candle, a paper, a concave mirror of the known focal length, a V-stand and measuring tape. Now let us do the activity. Now, take a candle, take a scale, take a holder which holds the concave mirror, a V stand. Now take a concave mirror and place this concave mirror on the V shape holder. Take a paper which you can have image formation on it. Now adjust the position of the concave mirror or the candle, and you find the object formation on the screen which is placed between there. So the light rays which will reflect from the concave mirror and images formed on the paper. Place the V stand at a various positions and see how the object is image is formed on the screen. Now measure the calculations for the image distance and object distance, and note down how the image size is varying. Here you can see at some positions the image is very clear, at certain distances the image is blurred, and at some points it is enlarged and other points it is not enlarged.